In today's video, we are going to see how the memory management happen in the operating system. So, in the past, this is how your memory look like. Okay. Let's start from 0 to assume that 128 KB. So some space is given to OS, and here only one process is running. Okay. All the memory is given to one process. So what happened here? This way of giving the memory is very big problem. Why? Because here if the process need any IO operation, so IO operation, the CPU is waiting, but still all the memory is given to one process, so no other process can work. So CPU utilization become very big issue, because during the IO no other process can come without completing this whole process. So CPU utilization get decreases very big. CPU utilization get decreases. Okay. So after this, a new way of memory management come, that is same memory, same OS. Here the process happen, but to increase the CPU utilization, we use context switching. So I hope you know what is context switching from my previous video. Context switching happen when the process go for IO operation, a new process come and switch this process. So the CPU cannot be ideal. So CPU utilization increases, and more process get completed in a less time. So throughput increases. I hope you know the throughput. What is throughput? This way happen it, but there is also a problem. What the problem here? That problem is starvation. What is starvation? I hope you know it. So basically, if there are 4 processes in a ready queue, okay, first process is of 1 hour, second process is of 10 seconds, third is 5 seconds, fourth is 10 seconds. So if first process come and it cannot go without completing this whole process, then what will happen? All the other processes which are very smaller in time have to wait for 1 hour, because the first process is very big. This is called starvation. So how this problem is solved in the memory management? We come in with a new concept that is called time sharing. What does it mean? Time sharing means that every process get the memory for a limited time. Okay. Suppose the time is 5 seconds. So if there are 3 processes in memory management, 1, 2, 3. First process come for 5 seconds and take the full memory. Second process come and take the full memory for 5 seconds. Third process come and take the memory for 5 seconds. It is just like round robin. Okay. But there is a big problem. What? Now if the first process is, suppose it is for 10 seconds, okay, it complete for 5 seconds, so it has to store all its attribute, all its data, how much is complete its process, what are next step to have to be done. It had to store in some place, and it store all its data in a disk. Okay. So the 5 seconds when it complete, it transfer its data to the disk. When next time this process come, it again reload its data into main memory. So the problem here is that main memory is very fast, but the disk is very slow. So here time is very much consuming. Time consuming is very high. Because of time sharing, time consuming is very high. So we have to take care of this also. So we come with a new great idea, that is called, in which what we will do is that there will be a big memory. Okay. This is a main memory. This is OS. In spite of giving this whole space to one process, we divide this main memory into different chunks. Okay. And give this to a process A, give this to a process B, this give to a process C. So for 5 seconds, CPU do the work of this. Okay. and all the data is saved in the this main memory. Then CPU will do B work and all the data and everything is saved here. Then CPU do the C process work and all the data is saved into main memory till when the till this process does not get terminated. Till the process does not get terminated and all the work of the process does not get completed, the process is present in the main memory and all its data in save is here. And it is one of the best practice because now you can do multi-programming, okay, with help of time sharing, okay. You have needed very less time because main memory is fast and you can save all the data. But there is a one problem. What happens if the process A use the data of process B disturb process C because everything is present in a one single memory. So how we can give the protection and isolation of each other? That is called abstraction. I hope you hear this word in a abstraction. How we give each and every process their own private place. So for this we come with the concept of virtual memory, and that is very important. This is one of the important concept, virtual memory, in which what will we do? This is a physical memory of our system, okay, physical memory. We divide this physical memory into different parts, okay. Suppose 0 to 8 is given to OS, 8 to 24, okay, and here 30 to 96, okay. This is a KB. We divide this physical memory into different KBs. Now we need to run two processes. So what will we do? There will be a two process, process 1, process 2. So what will we do? The process is not run, the process will not give its memory to from here, but process create its own virtual address space. Suppose this process 2 need 16 KB of memory. So this 16 KB is reflected to here. Suppose this need 32 KB or 64 KB, okay. So this space is given to here, okay. This is a virtual memory. This your main memory, physical memory become virtual memory, okay. And this is your virtual address space where the process run. So if the process allowed any value, suppose the x value is allotted at a 0 KB, 0 space here. So where this value is stored? At 8 KB in the main memory. Suppose in process 1 something data is stored at a 10 KB. So this data is stored where in the main memory or physical memory? It is stored at a 0 plus 10. So 32 plus 10, 42 KB. At 42 KB is this stored. This way the isolation of each and every process is happen, and this happened with one thing, that is no two process can be allotted same physical memory. What that is mean? There are two process 1 and process 2. These two process cannot be allotted with a same physical memory. It can't happen that 8 to 24 physical memory is allotted to process 1 and process 2. Otherwise there will be a no isolation, no protection. To give the protection, to provide the abstraction property, we have to provide different physical memory addresses to each and every process, okay. I hope with this example you understand the virtual memory concept, why we are using the virtual memory concept. I hope you see the evolution of memory management. First we start with a one process is running in a memory. Here the CPU utilization is low because if the process go for IO, the CPU will become ideal and CPU does not do any work. Then we come with a concept of context switching. But here the starvation problem happen if there is any process which has a very high time consuming, so other process has to wait very much time. Here CPU utilization increases, but there is a problem of starvation. Then we come with a concept of time sharing, but time sharing has a problem because every time after completing each process, its data has to be saved in a disk, and disk is very slow. So we have to come with another concept. Here all the data is stored in itself in the main memory, so we solve that problem, the problem of time consuming. But another problem come, that is protection and isolation. That property is called abstraction. So to solve that problem, we come with a concept of virtual memory. That memory, here the physical memory is not given to a process directly, but we create a virtual address space, and this is address space indicates some space in a real memory, so that protection and isolation is given to each and every process. I hope with this concept you will be clear how the memory management happen. We will discuss in later videos more deeply to each and everything about memory management. Till then, goodbye.